in this video we will discuss the problem K-Ary tree. So the problem says that you will be given a K-Ary tree, a full K-Ary tree, and what you have to do is you have to find the number of leaves in that particular given K-Ary tree, which is of height m, and you have to return the final answer modulo 10 to the power 9 plus 7, right? So now before discussing that what is a K-Ary tree, let's discuss what is a binary tree. So you know that in a binary tree, a particular node can have two children, right? At most a particular node can have two children, right? That is the definition of a binary tree. Now similar to this concept, K-Ary tree, or you can say N-Ary tree, right? In terms of this similar concept, N-Ary tree is a tree in which a particular node can have at most n children, right? It can have at most n children. A particular node can have at most n children, right? So that is what an N-Ary tree is. Now similar to this concept, that is nothing but instead of this n they have given k. So what is a K-Ary tree? We can say that a K-Ary tree is nothing but a tree in which a particular node can have at most k children, right? So that is what it is. Like it can have a particular node can have k children. And now the problem says that you have been given a K-Ary tree which is a full K-Ary tree, right? So now you must be knowing that if I give you a binary tree and if it's a full binary tree, right? So if I give you a normal binary tree, so this is how it looks like it can have sometimes it can have children, at most it can have two children, but it's not necessary that all the nodes are having two children, right? So this is incomplete binary tree. This is not a full binary tree, right? But if I have to talk about a full binary tree, so till this particular level, this is a full binary tree because every node has two children, right? Every node has exactly two children. If this is a binary tree, right? If this is a binary tree, then the thing is that this is a full binary tree because every node has two children, right? So that's a full binary tree. Now similar to this concept, what is a K-Ary tree? So suppose that the k value is 2, right? So in that case you have also been given the height. So height, suppose that the height is m is equal to, let's say, 1, right? So in that case what will happen? This will be the root, and this height will be 0, right? This is the height equal to 0, right? And then after that you will consider, so this node is the root, then after that this is the height is equal to 1, right? M is equal to 1, this is height is equal to 1, or you can say m is equal to 1, right? So at this level you can see that if the k is equal to 2, so if it's a two-array tree, right? Basically if every node can have two children, so it should be complete. Every node should have two children. So you can see that at this particular level there are two nodes, right? Now let's say if your k value was 2, but suppose your m value was also 2, in that case you will say that first of all there will be a root, right? There will be a root. Then for this will be the level m is equal to 0, that is height is equal to 0, right? This will be the level m is equal to 1, right? And at this particular level there will be two children, right? As you can see. Now at the next level you would be able to observe that m is equal to 2. At m is equal to 2, how many children you have? You have four children, right? And similar to this, like if I give you, let's say, m is equal to 3 instead of 2, right? So you will see that it will get extended, right? Basically this thing will happen, right? It will now have 8 children at this particular level, right? So first of all you can see that at the level m is equal to 0, you had just one child kind of thing, right? At this particular level m is equal to 1, how many nodes you had basically two nodes, right? At the level m is equal to 2, how many nodes you had? You had four nodes, right? At the level m is equal to 2, like at this particular level m is equal to 1, you had two nodes. At this level m is equal to 2, you had four nodes. At this level m is equal to 3, how many nodes you have? You have 8 nodes. And if you will go one level down, so you'll have 16 nodes, right? So it is changing exponentially, right? Basically it is nothing but if you have to find the number of nodes, the number of leaf nodes, that is, suppose that this is the last level, right? So that all the nodes at this level will be considered as the leaf node. And how do you get this? So basically whatever is this, right? K is equal to 2, so this is a two-array tree, right? So in that case what you will say is that the answer will be nothing but power of 2 comma 3, right? That's nothing but 2 to the power 3, right? So that's the answer. And you can see 8, right? Suppose that if m is equal to 4 was there, so in that case 16 would have been the answer, right? So if 2 to the power 4 will be 16, so that's how you can calculate it. Now let's try and see for if the k value was 3, suppose if the k value was 3. So if my k value was 3, so in that case what will happen is every node will have 3 children, right? So you can see that this is m is equal to 0, here I have one child. Just at m is equal to 1, how many children do I have? I have 3 children, and that's nothing but 3 to the power 1, right? And if I'll go one level down as well, so you can see that this particular guy is having 3 children. Then the next node also is having 3 children. Then this node is also having 3 children, right? And this is what m is equal to 2. So this is height is equal to 2, and here you have 9 children, right? And that's nothing but k to the power uh, k to the power nothing but 2, right? That's nothing but 3 to the power 2 is equal to 9, and that is how you can get the children, right? So basically now what you can say is that basically if you are given the value k, you have been given a k-array tree, that is the number of nodes, the number of children that a particular node can have, that is the value k, and you have been given m, the height. So you can easily say that the answer will be k to the power m. And what you can maybe do is you can mark your, let's say, p, or you can mark your answer as 1, right? Initially you will say that your answer will be 1, and what you will say is that for you will run a loop for int I starts from 1 and I is lesser equal to m and I plus plus, right? And what you will say is that every time you'll keep on multiplying k, right? Answer asterisk is equal to k, right? And that is what you will think that you can do. Basically what you do is you do k into k into k into k, right, up till n times. That is what you can do. And if the k value, if the m value is 0, in that case you will simply return the answer 1, because this loop is not going to run. But if you are calculating the power in this way, right, if you are calculating the power this way, so what happens with this way is that actually it will take a lot of time, right? It will take order of m time, right? And can we do this better than this? Yes, we can do this better than this concept, right? Because if you will try to think, you could have also done it recursively, right? Maybe what you could have done is you could have written a recursive function, right, for yourself. And like what is the recursive relation? So you can say that basically if you are calculating let's say k to the power n, like let's say you are calculating k to the power n, so k to the power, let's say, m only you are calculating. So if you are calculating k to the power m, k to the power m is equal to nothing but k to the power m minus 1 into k, right? So that's the recursive relation that you can build. And k to the power m minus 1 is equal to nothing but k to the power m minus 2 into k, right? That is what can happen. So basically you will have int k comma int m, right? This is what you will have. And what you will say is that if m value was 0, in that case you could have said that you will return what? You will return simply 1. But otherwise what you will do is, otherwise you need to get this answer, right? First of all you need to get the answer for m minus 1, right? So in your temp what you will do is you will call recursively for k comma m minus 1, and then what you will do is you will return nothing but k into temp, right? That is what you will do in a normal recursion. But this will also take order of m time. Why? Because first of all you are calculating for mth, then k of m minus 1, then k of m minus 2, right? Up till this time, until m is equal to 0, right? So basically how many iterations you will do? Order of m iterations you will do, right? And that is going to take a lot of time. But same concept, what you can do is, same concept we can try to modify a little bit, right, because of some observations. So what we can do is, basically if you have to calculate, right, k to the power m, right, so you can do this more optimally, right? You can use something that is known as kind of binary exponentiation, right? You can use this particular concept. What does this concept say? So basically, as I told you, right, if you are given to calculate k to the power m, so you will say that k to the power m is equal to nothing but k to the power m minus 1 into k, right? So that's the recursive relation that you can draw. And you will say that k to the power m minus 1 is equal to nothing but k to the power m minus 2 into k, right? This is what you will say. But the concept that lies ahead of this concept is that basically you can try to reduce the number of calculations. Basically suppose that m is even, right? If the m value is even, then what you can say is that k to the power m is equal to nothing but k to the power m by 2 into k to the power m by 2. Now what does that mean? So basically, let's say if you have to calculate let's say 16, or if you have to calculate, let's say, thing like 2 to the power 8. So in that case what you can say is that 2 to the power 8 is nothing but 2 to the power 4 into 2 to the power 4. So how does this thing help? So basically I can say that if I just calculate 2 to the power 4 one time, right, and then I can multiply it 2 to the power 4 into 2 to the power 4 itself, and then I can get the answer, right? And similarly this thing. Now if I have to calculate this thing, right, if I have to calculate 2 to the power 4, let's say, so if I have to calculate 2 to the power 4, so 2 to the power 4 is equal to nothing but 2 to the power 2 into 2 to the power 2, right? And that's how I can build the general concept, right? So you can see that if I just calculate 2 to the power 1 time, 2 to the power 2 one time, so 2 to the power 4 one time, right, I just calculate and multiply it with itself. And if I calculate 2 to the power 2 one time and I multiplied it with itself, so I'll get 2 to the power 4, right? So that's how I can reduce the number of calculations, right? So basically what I'm saying in terms of this thing is that basically what you do is, if your m value is, let's say, even, right, so what will happen? Your k to the power m will be nothing but k to the power m by 2 into k to the power m by 2, right? And your k to the power m by 2 will be nothing but k to the power m by 4 into k to the power m by 4 and your k to the power m by 4, right? You do this until you reach k to the power 0 or k to the power 1, right? So k to the power m by 4 is equal to nothing but k to the power m by 8 into k to the power m by 8, right? So you can see that you just calculate this once, k to the power m by 2 calculate once and multiply it with itself. You calculate multiply k to the power m by 4 with itself, k to the power m by 8 two times, and then you will get k to the power m by 4, right? That's how you can get it. Now after this part is done, right? So you will say that what if m value is odd, right? If m value is odd, then what can happen? So if m value is odd, so you will say that k to the power m will be what? Let's suppose that you have to calculate 2 to the power 9. So 2 to the power 9 will be nothing but 2 into 2 to the power 2 to the power 4 into 2 to the power 4, right? That's nothing but k into k to the power m by 2 into k to the power m by 2, right? So that's how you are doing it. And now let's try and see like actually what will be the time complexity in this particular case, right? So you can see that if m value was odd, if 2 to the power 9 was there, so you multiply 2 first of all, and then you do 2 to the power 4 into 2 to the power 4, right? So you have to multiply one more 2, right? That's what you have to do. And now basically the concept that is important in this particular problem is that you can see that first of all what you do is, if you want to calculate k to the power m, so you first of all calculate k to the power m by 2, then you calculate, if you want to calculate this m by 2, so you calculate m by 4, right? That's how you keep on calculating, and that's nothing but first of all m, then m by 2, right? And then m by 4, and then what, m by 8, like up till you reach this 1 value or 0 value, right? So basically if you will try to focus on this part, so how many number of calculations you actually have to do, right? Suppose that if you had to calculate, let's say if your k value was given as 5 and your m value, let's say, was given 64, right? So if you had to calculate 5 to the power 64, right? So that how many number of operations you will do? So from 64 to 32, then what will this value be? 16, then this will be 8, this will be nothing but 4, this will be 2, this will be 1, right? And you can see that's how we are the operations are getting divided, and this is nothing but log base k m, right? This is what the time complexity is, because you can see earlier it was what, if you had m is equal to 64, so it would have been taken 64 operations, that is order of m. But in this case it is just taking logarithmic operations, right? Because if this is this much part, so basically this is what will happen. So it will become nothing but log of m, right? Because you can see that the number of operations are how much? 1 2 3 4 5 6 and 7, and that's very less compared to 64 operations, right? So that is why the time complexity would reduce to log of m, because every time your input is getting divided by 2. Let's try and quickly implement the code for this particular approach, right? So also you have since the answer can be very long, so you have to return it modulo 10 to the power 7, right? So let's try and see what we can do. So basically what we'll have is, we will do what, basically we'll have a long answer, right? Initially we can initialize it to 0. After that what we will say is that answer is equal to nothing but what answer is equal to nothing but we will make a recursive function or a power function for ourselves. Let's say we make a recursive function for ourselves, right? And what we pass in it is k comma m, right? We pass this and we do modulo m, right? Because every time we have to keep on doing the modulo thing. So I can say that long mod is equal to nothing but 1 e 9 plus 7, 10 to the power 9 plus 7, as we have to get this much modulus, right? And then after that what you do is you simply return the answer, right? And we will have a recursive function for ourselves. So that is nothing but long recursion, right? And in this particular function what I'll pass is, I'll pass nothing but int k comma int m, right? That is what I'll pass in this particular function. So what I can say is that if my let's suppose that first of all I'll have the long answer, right? I'll have the long answer initialized right? I'll have the long answer, or let's say I'll have nothing but long temp, right? So that is what I'll have first of all, and I will say that if my k value is, suppose that my m value is 0, right? So if I'm at the very first beginning, right? If I just have one node, in that case I'll simply return 1, because I do not have any level, right? Otherwise what I need to do is I need to calculate this this temp thing, right? In my temp what I'll basically calculate it, in my temp I will say that I'll call recursively I'll calculate k comma m by 2, right? Because if I want k to the power m, so first of all I should know k to the power m by 2, right? And I will also take the modulus, right? That is what I will do in this part. After this temp is calculated, so I need to check that if it happens that currently if it happens that my power, right, if my m mod 2 is equal to 0, right? If it's equal to 0, in that case I can simply say that I'll return nothing but k to the power m by 2 into k to the power m by 2. That is nothing but temp into temp and modulus mod, right? That is what I will do, right? And otherwise else, if it happens that m value is odd, right? So in that case, what should I return? I should return simply nothing but what k modulo mod, right? Because I should multiply k one time more to it, right? K into what, temp modulo mod, right? Into this thing, that is temp modulo this part temp, and then modulo mod, right? So this is what I should be doing, and I should take the whole mod, right? That is what I should do, and that is how I'll do it. Because if suppose that k, if I had to calculate, let's say 2 to the power, let's say I had to calculate 2 to the power 4, so that will be nothing but 2 to the power 2 into 2 to the power 2, right? So that is what it will be. But in this case, like, that's why I'm doing temp into temp, because if I want to calculate k to the power m, so k to the power m will be nothing but what, if I want to calculate k to the power m, so k to the power m will be nothing but k to the power m by 2 into k to the power m by 2. So if m value is even, but if m value is odd, then I need to multiply this k one more time, right? Because if I want to calculate k to the power m when m value is odd, right? So suppose 2 to the power 9, so in that case I'll say 2 into 2 to the power 4 into 2 to the power 4, right? So basically this is why I'll if m value is odd, so k into k to the power m by 2, right, into k to the power m by 2, right? So that is what I will be doing. Let's try and quickly compile this particular code and see if it works on the samples or not. So it is giving the output as 4. Let's try and submit it as well. You can see that it was able to pass all the test cases, and that is how you can do it. And basically for doing this particular problem, as I said, since you are using this particular approach, binary exponentiation, so the time complexity for this particular approach will be order of log m, right? And the space complexity will be order of 1. Thank you for watching this video.